You can look, but don't touch. These arcs of plasma are lethal enough to kill on contact. In this project, we're using an old microwave oven transformer to extract these traveling electric arcs. In a previous video, I found a microwave in my neighbor's garbage can and salvaged this iron core high voltage transformer. This is heavy metal. The primary winding is around 100 turns of insulated wire, and there's somewhere around 1,000 on the secondary. I'll pull these clips off the primary to expose its two terminals and pull this middle wire out of the way because I won't be using that. I've got the secondary winding connected to some 14 gauge wire and then taped to a nail on the end of this wooden stick. This setup should insulate my body from the circuit. The other end of the secondary winding is grounded to the iron directly, and when I put power to it, I can draw out some high voltage electrical arcs. In order to get these arcs to travel upward like this, I'll need to form a V-shaped spark gap. I don't have any metal coat hangers, but I have some uninsulated 14 gauge copper wire that should work. I'm cutting these two pieces roughly 2 feet long and using this piece of glass I salvaged from the door of the microwave. Adding pressure and rolling the glass back and forth seems to be an effective way to get the kinks out. 3 inches of the wire is bent 90 degrees, then folded back in half, and using pliers to bend the tips over, it looks like this. Holding everything flat, I'll trim the tips and curve them over, and that's pretty much it. This small piece of wood should work well as a base for the spark gap. So 2 holes are drilled and screws added to hold the copper electrodes in place. This wire is soft, so I can easily form it into a V shape, so that the closest contact points are 3/8 of an inch apart. The top is just over 20 inches high and about 1 inch wide. To make this insulated safety stick, I simply hammered a nail into the end of a wood 2x2 and proceeded to cut the head off using a hacksaw. The MOT voltage isn't high enough to jump a gap this wide, so the nail body will help it get started. To add power, I'll use the cord I scavenged from the microwave. I've added alligator clips to the wires and made sure the green wire is out of the way. The black and white get clipped onto the primary coil, and these separate clips connect to the secondary winding and the outside of the transformer body. Now I can plug the cord in, flip on the power, and with one hand behind my back, aim this nail right between the gap. And there it goes. This is lethally high voltage, but not quite enough to start on its own. The electrode wires diverge at a very slight angle, slowly stretching the arc as it travels upward. It's impressive at how much it grows at the top before it breaks. Shaky wires make the arc less stable and cut out before reaching the top. I'm inside the house now to get out of the wind, and when this one sparks, it takes off like a rocket. The unballasted arc behaves almost like a short circuit, drawing power until the arc snaps, or the circuit breaker pops. I can't think of any practical use for this. It's simply quenching my curiosity. This airborne electricity is rocketing upward because it's heating the air around it, and the hot air rises. They might look harmless enough, but don't touch, because contact with the exposed high voltage conductors can be lethal. That's why I have gloves and a safety stick. I've just narrowed the spark gap, and now when it shorts out, I've captured a glowing orb of electricity. I have to look away because of all the UV radiation flying out of this thing. I still have this high voltage capacitor from a previous video, and I'm wondering what would happen if I added it in parallel with the spark gap. Let's find out. Yikes, that's one super spark. Because this is indoors, it's easy to make this into an ozone generator. Right now, this is ionizing oxygen and nitrogen into ozone and nitric oxide gases, at least until the breaker pops, and perhaps that's a good thing since the gas is poisonous. Well, I'm still alive, so this is probably a good time to power off and disconnect the cord. It's extremely important to safely discharge the capacitor before I remove these lead wires and put everything away. I can tell this transformer took some abuse because it's extremely hot and hard to hold on to. If you like watching these projects, please support me by being a subscriber and sharing with your friends. I appreciate your support. Thanks for watching.